Sorry.
So here I've got a question for you guys. Here, which program do you use for controlling your astrophotography equipment? Nina, SG Pro, Alice, AS Air, other. Please specify which one. None. I'm not using anything. So
I think none is the answer.
Most of us say, well, none for astrophotography. That's one. Let's see how many. If I click on none and click on submit, let's see if they give us any results here. And 3% none. Other probably is like what, PhD 2, right? 20%.
Yeah.
Nebulosity.
Nebulosity. Okay.
That goes along with PhD 2.
Oh, for controlling, I thought they meant storing. Never mind, I see it now written there.
And then ASI Air, that's interesting. 22%.
I never heard of those top 3 things.
Yeah, SG Pro and well, Nina's the one I think that you know, part of what Hank uses as part of the Linux type of program, nighttime imaging and astronomy. I think that's what probably Hank gets into. So that people probably go back down and explain more with their ecos. Yeah, like Hank.
Yeah, ecos. That's what he's using.
K-stars.
Yeah.
The Raspberry.
And the Raspberry Pi. Yeah.
And not easy to answer your poll. You only ask for one program, but many use not only one. I use 6 programs simultaneously to control the gear.
Oh my.
Nina 1, Mount Wizard, UPB, environment sensors, focuser tools, PWI, tap.
Oh yeah, I use focuser tools. That's not the name of the program, but I use focuser programs.
Huh.
And
Do you use batten off mask then to get fine focus?
Yeah,
well,
I use
would,
a batten-off mask.
Yeah.
But I have to move the focuser. And it takes software to move it.
They're talking about software here, aren't they? Yeah. What program do you use? Yeah. I cannot not complain about ASTAP. Wrong settings or too poor image quality for ASTAP, whatever that is. So this is astrobin.com and got a little forum going on here.
What's AstroBin?
It's where the people post their astrophotography. It's just amazing, you know, work that people are doing.
So it's a chat room like Cloudy Nights.
Well, no, I mean it's more for posting your images.
Oh, okay.
So it's what's this here? M3.
Well, that's a nice picture of Clavius over there.
You saw something different? You saw, what'd you see?
That was a nice picture of Clavius over there.
Oh, the moon crater? Yeah.
Oh.
Yeah. It's 1, 2, 3, 4 down on the right column.
Oh, sorry. Okay. Get there.
Go to the left.
Over here.
Yeah,
Clavius.
that's it.
Yeah, boy, it looks real.
Oh, that's so neat.
Let's see if I go full size.
Oh yeah, that's snappy.
Oh, that's sweet.
That is snappy.
It's some
Wow, look at
elevation
how
to
clear
get
that
that clear.
Yeah.
Oh my gosh. That's something.
I wonder from where that was taken.
Must be someplace really clear and very little
Clear and high, you know, like Mount Pinos.
It was from the Lunar Reconnaissance Orbiter.
Yeah.
Really? Okay.
I can't believe how clear the crater is. I mean, just every little. Wow.
So I wonder, you know, they talk about there's like 300,000 craters bigger than a kilometer in diameter on the moon on each side, I think. So I wonder what a kilometer would be, maybe something like that. But
I think probably that or smaller.
even smaller. Wow.
Yeah, I think these are like Clavius. I think that's hundreds of kilometers across.
That's really, wow. I mean, Tycho is 60 miles across, 100 kilometers.
Is that Tycho up above?
I don't know.
Up there to the right, left, and
I
It
don't
looks
see
like
any.
a structure of Tycho, but I identify Tycho by the rays, and that only shows up under a full moon.
Right.
That's Albateus over there. It has a little peak in the middle.
Oh, now you're breaking up, Bruce, a little bit.
Well,
That sounds like an audio cable problem.
Well, Bruce had moved his Wi-Fi extender farther away from his tablet, and it seemed to help, but something's gone back.
Back to the built-in microphone tablet.
Yeah, that sounds good.
That does, yeah.
All right.
Well, there was a little break there. I love sunspots.
Yeah.
These are new ones too. These
Yeah,
are
there's some nice ones up there now.
Yeah. Let's see what if I go to space weather. What's he showing here?
That I've gotten of the sun and of the moon are taken through my 5-inch scope. It's less affected by atmospheric turbulence than 11-inch.
That's smart.
Well, it is because an average sun cell is about 10 centimeters in diameter, inches.
Oops. And then you always got to go down. Oops. Here's our morning planets, huh?
Oh, they're all in the morning. Wow.
Yeah, look at them lining up.
Wow. Shoot. Now, if I had that C14 going, I'd get up early.
I love the spaceweather.com. You can see the fireball patterns and then who's going to hit us, which asteroids are about to hit us here. What's today's date? Today's the 19th. 15 lunar diameters, 39 meters in diameter. Oh, that's pretty big. 39 meters. It's 100 feet in diameter. Wow.
Huh.
And here we have a kilometer in diameter, May 27th.
It's even got cosmic rays.
Yeah, yeah. They do a balloon here. And
Huh. Oh, wow. That's amazing.
can't remember what do the cosmic rays. They go down when there's more sunspots. Is that what happens?
When is that we're supposed to get a cosmic ray impact? Oh, that was last October.
Like 39 meters is 128 feet.
Huh.
Yeah, yeah. Yeah, here's, it's always interesting to see the radiation versus your altitude, how that changes on your.
Well, I have a small Geiger counter with me. It's about the size of a calculator. And here down at sea level, you get maybe 4 counts a minute. You get up in the airplane and it's making noise.
Yeah. Yeah.
Wow.
Radiation illness is prevalent among airline pilots.
I'll be darned. Huh. Just that much makes a difference.
Yeah, they're constantly up there.
Well, I've heard that an airplane across the country, the radiation is about equal to what you get a year at ground level.
Your voice is garbled, Bruce.
Say again?
Your voice is garbled.
You had some breaking up there, Bruce, again, but when you get
It
close to the
sounds like-
tablet, it might be better.
Sounds like harmonic distortion. I suspect you might have an impedance mismatch at some cable.
And Bruce, did you change the audio input when you took your headphones off, or were you still on your microphone on the headphones?
I was on the microphone, was in. Now I'm back on the headphones.
Yeah, that's
Yeah.
clear. Clear as a bell.
Well,
All right.
it's
Well,
still, no, it's breaking up on the headphones there too.
You can't win.
It was great for a moment.
It was clear during the astronomy hour yesterday.
Yeah.
yeah.
Speaking of which, let's see, how many people did we have that are looking at our show yesterday? Got 10 views yesterday.
That was the one tomorrow morning, yesterday morning?
Yeah.
We've got 22 subscribers, I see.
Yeah. Probably two of mine.
Two.
But yeah, but let's see, our Mirek Brandt exoplanet show has up to 43 views. But again, if you start looking at the how many real views that you're really getting, let's see if we can find that. They're live, and click on the show and look at analytics. And the watch time, 3.7 hours total watch time for 23 views. Didn't get 23 hours of watch time. And
It looks like people didn't log on until pretty late.
well, I think it includes people that are might be watching today. They somehow looked at the video and they saw the first minute, and then they dropped off. So here's the people watching our live stream. We had 7 people at the same time when Tim came on. Of course, one was me, and then we had Jim, and we didn't see Chrissy log in, did we? Well, maybe Chrissy said hi, so Chrissy was on.
What show was this? Yesterday?
Yeah, no. This was the first Friday.
Oh, okay.
First Friday show.
See, this is way too much information. I don't do it for ratings.
Well,
I gave that.
So
I
average
gave that up a long time ago.
So here's the average view duration is less than 17 minutes of the hour show. 30% viewed. I can't read this chart somehow.
Well, they probably really dumped us after my medical report today. So.
Yeah. Well, again, today we're not live. Mondays and first Fridays are live shows.
Oh, okay.
Oh, I thought we were live.
No, we're just recorded.
We're recorded. Okay.
Yeah.
Oh, well, we should be live so people can phone in with questions.
Well,
That's
we could consider doing that.
Yeah.
And again, my executive decision is that in May we'll do first Fridays, and we'll do on the second Tuesday, we'll do second and fourth Tuesdays for the telescope workshop, and we'll start at 7 p.m. a little bit earlier because Bob Richard appreciated being a little bit earlier at 7 p.m. And then on the third Monday, maybe we'll do an Astro hour, and then that leaves room for going out to outreaches, and second Saturday, third Friday.
You're not going to support Astro Hour every week then, huh?
No, just once a month.
Okay.
And we got the general meeting the first of the month, and then telescope workshops, on the second and fourth weeks, or fourth Tuesdays. So that'll cut it down a bit, and maybe I'll find more time to work on the website or work on my house.
Or both.
Yeah, both. Yeah,
Yeah,
and by the way,
we're going to cast around and try and find a backup for you so that you're not a single point failure.
Right, yeah.
So that you can take the time off you want and need.
See who wants to tune in and help take over. Yeah, because I got to go on a vacation, go see my mom in Michigan here at some point.
Right.
Maybe longer. All right, so where were we? So Tim and I were working on the Star Splitter telescope and found out that it's quite the character. It's got character. Let's see if I can show one of the images. So Jerry, have you seen our emails today coming through?
I think so.
So this is the mirror cell.
Yeah.
And it's got 3 floating spots, 3 points on each one. It's got the little three side pins, that nylon screws that come in the side, and it's got these black knobs are for holding holding the little tabs that go on the front of the mirror, that go over the front of the mirror. They get held on by the little black knob, but there's a nylon screw that comes through here that pushes on the side of the mirror. The mirror is probably what, 1.5 inches thick or something. Let's see how thick is a mirror. It's like that thick. An f5, 62 and 5/8, made by Enterprise Optics.
Is this a 12-inch mirror or a 12.5-inch mirror?
I don't know. Tim says 12.5.
It's 12.5, I believe.
Okay.
And
Most importantly in this photo is the screws that you're seeing in between the triangles.
Yeah.
flathead
Okay.
bolt screws.
Those correspond to the collimation knobs in the back of the scope.
Right.
But how they're if you show that drawing, Tom, it's going to be most interesting. Actually,
Let's see if I can find that. See if I can find that.
I've been
drawing.
looking at that carefully tonight, and I can't make heads or tails of it. It needs to be shimmed, but let me explain what I think. It's I'm not exactly sure. Okay, here we go. So at the top, the bolt is the screw head that goes right through the mirror cell. Now that bolt, which with the image here is not exactly accurate, because what happens is there's quite a space between the mirror cell metal and the rubber grommet or bushing that's just sitting on the inside surface of the wood base in the mirror.
There should be no space between the rubber grommet and the back of the mirror cell metal.
No, Jerry, it's not made that way.
Tim, yeah, it is. Tim, it is. I mean, the metal of that mirror cell sits right up against the rubber,
Right.
and the bolt has a little give point, so it's got a nut that holds the bolt in place, firm against the metal.
Tom, I disagree. If you see that the nut and the nut in the washer that's sitting inside in the inset of the rubber grommet,
Right.
okay, that tightens against the bolt.
Right. That holds the bolt in place, makes it a part of the mirror cell metal.
Right. That's what I'm showing right there. I got the lock washer and the nut, and they're tightening the flathead screw against the metal plate for the mirror cell.
Yeah, this is pretty straightforward, and it looks like it's a real good plan. It's very similar to what I made for my 18-inch. But my curiosity is that those triangles that sit on the mirror cell metal, and they're not shown in this diagram, what is it that the mirror cell, that those triangles balance on?
Yeah. Let me see that. I got that other picture.
They sit on little through bolts.
bolt.
You see them right there?
Yeah.
They're nylock screw, nylock nuts. And,
So those triangles sit on those nuts. What's this big screw in the back?
That's these coming through, going through the back.
No, no. On the other, go look on the previous picture. See that? Now, no, previous picture. Oh, there it is. See it right over his knuckle, right there. What's that?
That goes through the back for the black knob to tighten against. So this nut it gets tightened down like I had in the drawing there.
So there should be 3 short screws coming through, and each triangle sits on those.
Right.
Okay. So then what's that long one? That would bump into the mirror then.
No, this is upside down. So this goes through the back to the wood like that diagram showed.
That's right. That goes through the back of the mirror box.
So the triangles are on the other side of this.
Yeah.
Yes.
Okay.
And you can
wait. So that doesn't answer my question. Then what does the triangle sit on?
It sits on
the head of these screws.
Yeah, on those short bolts. It floats on those short bolts somehow.
Yeah, that somehow is what I want to see.
You know, we never got we didn't get underneath that. I don't think. What I ended up doing is taking that. You can see where there's wires there that connect all the triangles together, and all we did was unscrew that and put the wire underneath the nuts. But what suspends the triangles upwards?
Yeah.
I don't know.
Okay.
My suspicions are that it is a nut or on the other side of this of the center bolt there that he's got the cursor on. There's a bolt on the other side that
I don't think there's
I
don't think there's a nut under there. It's got to be something pretty flat because these don't sit that far up. So, you know, you got this, somehow these things can wobble. There must be like a little washer.
Yeah.
It's got maybe a washer.
I have a steel ball bearing that it sits on, and there's a recess in the triangle and a recess in the plate below it.
Oh.
It looks like the triangle is like a flathead screw, you know, bolt going through.
Yep.
You know, and this is the back side here.
Well, then that wire.
Oh, you know what? You know what? This is a this is a nylock nut, and it's not tightened down all the way. So there's a little bit of give. So it doesn't fit. It doesn't fit tight against the plate, I don't think. So that's why those three plates why they can move is because it's not tightened down.
Okay.
I think that's it. But
I think that needs a redesign.
Shouldn't that wire be in tension? That wire?
No.
I'm trying to figure out what is that for.
The wire, if you have these triangles sitting there and they're free floating on a point, a fulcrum, they might, when you lower the mirror down, one of these triangles might move, say 60 degrees. And so then it would be off. It's not in this pattern. So the wire is just loosely there. You could use a thread.
Okay, so it is supposed to be loose. It's just to hold them in place. So they don't
to roughly the right angle.
Gotcha.
So those were disconnected when we found it. So what I did is I put the wires underneath.
Yeah, I don't have anything like that in mine. The thing is sitting there and it's free to rotate if it wants to. But I line them up and then I lower the mirror on them, and they will not rotate once it's on them.
right.
So the other thing is that maybe I think that if you revisit that one more time, these triangles, they float, and so the mirror can float, but I mean they're loose, they move, they walk.
Yeah, one of them isn't floating. One of them is too high somehow, and that's why it takes all that tension to counterbalance it.
So maybe that's where our adjustment can come in.
I would suspect that's where we'll find the adjustment.
Okay.
If we make those things uniform height, then everything should be fine.
Well, if you're correct that there's a ball bearing underneath with a hole.
No, I don't think that's how I designed it.
Yeah.
And I think that's a better design. But this is obviously, as Tom points out, this is obviously a screw head.
Yeah.
So probably a little sting around this when it comes to the triangle.
Bruce, you're breaking up again. It's really bad.
I like the use of the word bangle.
See, even if the nuts on the back were loose, Tom, that those floating triangles, they just seat right against the mirror cell.
That's right. They seat against that. You want them to seat against a single point fulcrum. You don't want them to seat against arbitrary 3 points on the mirror pad.
Yeah, and so there's something creating a fulcrum underneath these triangles, and that's what we got to find out.
Yeah, if it's not the fulcrum, a single fulcrum, then it'll find 3 points at random through the roughness of the surface, and it'll balance there. So you got to have a single point fulcrum higher than all the irregularities on the thing. We'll have to look at this when we second Saturday.
All right. So when you tighten, if you can imagine, just to let you know one more thing is when you tighten on the back of the scope, there's 3 knobs, one at 12 o'clock, one at 4, and one at 8.
Yeah.
what's happening is the bolt on the back that's at 4 o'clock, the knob on the back
Yeah,
that's at 4 o'clock, you have to tighten down as tight as you can.
right.
And
I understand the symptoms.
yeah.
So in other words, you're at your end on the travel on that screw on that.
Yes.
Absolutely.
And
Because what I've had to do on mine is, you start tweaking it, and then you get to the point where you run out of thread. So you have to back them all off. See?
Yeah.
Yeah, but the other two are loose to begin with. There's no tension on them at all.
Okay, but you could still back them off enough to where they will all tighten down so that you can get that thing lined up and culminated right. That's what I have to do on mine. I run out of travel, and so then I just back everything off.
Yeah.
And then start
It won't work, Dick.
Oh, okay.
I tried it. When you back off the other knobs completely loose, and then you back off
And
the
then
other
you're
one.
screwed.
Yeah,
Okay,
and so
yeah.
when you're looking down the tube, let's call it the tube, and you have my lasers in there, and you can see the reflection of the secondary, the other dot in there that's floating. It's to the upper right at 2 o'clock, way off.
Oh wow.
And so as I tighten that knob at 4 o'clock, it starts pulling that secondary dot towards the center. So what's happening is that in my mind, I had it backwards. What's happening is when you tighten that knob, you're compressing the rubber. So it's actually instead of what I was thinking was happening is it was pushing the back of the mirror box forward. It's not doing that. Well, actually it is. Because it's compressing, it's essentially kind of moving the back of the box forward, right? On the right side, and for some reason that pulls that dot down into the center. So I'm still not getting that image in my mind right. It just doesn't make sense. But maybe what has to happen here is exactly what Jerry's saying. Is find out what the fulcrum on the back of those triangles is and shorten 2 of them.
No, I think something is just unseated and it needs to just be seated.
Well, that might be, but I don't know. I don't know about that.
Yeah.
But the rubber, you can see the rubber bushings in this photo.
Yes, you can.
And then so what happens is that the whole, the female part of the grommet, what goes in there is a nut that tightens against the bolt coming from the other side of the mirror cell. And there's also a washer in there. So the washer's inside, and then the bolt tightens down really hard against it. And so it's tightened against that rubber grommet. So now when you push, when you tighten the knob in the back of the scope, I think what it's doing, I'm just not getting it, because I think it's kind of like it's either pulling or pushing. It's pulling or pushing that grommet. I have to look at it again. I just have to look at it.
Yeah, we all need to look at it.
Yeah.
Okay.
Any other topics here? What else we got to talk about?
Oh, no.
Who's got a title? Mike Chipnick is joining us. Maybe we missed him because we were doing sharing for so long.
Well, my observatory got painted today, so it's flat midnight blue on the inside, and my wife's having some treatment on the outside called faux, which is you paint a base color on it and you dry sponge on other colors. So it's supposed to blend in with the rock wall behind it, which I don't care about. Fine, up to her. So, and then I'm remeasuring for the final time the focal length of my 18-inch mirror, and then I'm going to cut the holes in it and put the scope together probably by this Friday.
Wow.
And then we'll start putting the mount and stuff in the observatory probably over the weekend. Let's get it close.
Good.
So say goodbye to the fair weather.
So Jerry, which mount were you using? Astrophysics 1100 or something, or what was it?
1600.
1600.
Yeah.
The big boy.
Yeah.
Yeah.
That's gonna be
Well, I
problem.
have, the 3600 is the big boy, which apparently Astrophysics developed specifically for NASA, and it was meant to be used at the South Pole. And so all these mounts come with a version that they call a cold version, which means there's absolutely no lubricants inside to freeze. It's just different metals on each other that don't gall. Mine is not going to the South Pole, so I have lubricant in it. The one that you show there on the right, on the right of the two parts, that weighs 50 pounds, and the other one weighs 35 pounds.
Jeez, it's a good thing it comes in two parts.
Yeah, yeah.
Well, that's what forklifts are for.
Yeah.
Yeah.
Still 50 pounds is 50 pounds.
Yeah, I think I'm gonna have to get a shaft extension for mine too. For the
Why for
1100.
Why a shaft extension?
Because I think that you probably need to have about as much shaft length as you do scope length on the other side. See, so if you're putting a 14-inch and then on with rings, and then you're putting an aiming station on top of that, and then the MP127IS, you're probably stretching this thing out to, you know, somewhere around, I don't know, 24 to 30 inches. So you're going to need to have extra shaft length just for that reason alone, to counter the weight.
You can't just put heavier weight at this.
Well, you can to a certain point, you can, but if you've got an overhanging load on the other side, see, you're going to have more shaft length on this side to counter that overhanging load. So it's a moment arm is going to be greater. The greater the radius, given the same amount of weight.
Jerry, what's your telescope assembly going to weigh?
I think it's going to weigh around 100 pounds.
Wow. Yeah, you could use 1100, but that's close to the top. I think mine's about 92.
Yeah.
Boy, it ain't cheap.
No.
It's gone up about $3,000 since I bought it,
Wow.
Yeah.
which was in 2016.
When I talked to the gal, she said they're going to start sending out notifications for the 1100
Yeah.
soon, in the next few weeks, is what she told me. So hopefully I'll be getting that. So that's all I'm waiting for, and then I can get that big scope on there.
Yeah.
We can have star parties on Tuesday night.
Good idea.
Yeah. Yeah, Jerry can show his scope and I can show mine, and we can have all kinds of fun.
See if people can spot the libration difference from Paso Robles and Calita.
Yeah, there you go. Well, you know, and then you could have people, you know, if you wanted to have a live show, well, shoot, they'd go, you know, what does such and such a thing look like, or whatever. You could maybe.
Yeah.
Why is that Mach 2 more expensive than the 1100? I thought that was a smaller mount, smaller load mount, the Mach 2.
It is. Where do you see that?
But he just went by it. There was an 1100 on the bottom, and then all of a sudden, and then there was a Mach 2, and it was 10,000. It was another $100 more, or 1,000 more, you know, than the 1100. I don't get that.
I wonder if it's got encoders. Absolutely.
Yeah. It's about $5,000 or $6,000 to get the encoders on it, and I do not have encoders.
Oh, really?
Oh
Yeah.
yeah, they're expensive. I'm gonna get them on mine, but
Yeah.
And the only reason why is just I'm thinking shooting across lunar cycles and just being able to frame it all up right with the magnification.
Oh my God. Yeah, it is $5,000.
So Tim, don't you have some leftover gold from working on all those teeth?
Oh my God, there ain't enough gold in the. No way. I have a little Takahashi mount. It's a non-go-to version. It's got to do for me. I hardly ever take it out.
That's the thing. Got to get serious with this stuff. Do your astrophotography.
That Mach 2, I thought, that was the one that I thought, even if you got the 5-inch, well, maybe not, because, Dick's got the 5-inch. And he's using the 1100. My God, the weight of all the stuff going on it's tremendous.
Yeah, it's going to be up there at the top.
Yeah, the Mach 2 is portable, 42 pounds.
Yeah, but what's the max? See the max version. Well, wait a minute. What will it load?
What's the payload? Yeah,
capacity 75 pounds.
That's not too bad.
No.
Now I think Chuck is getting one of these. I believe Mach 2. I don't know if it's Mach 2. Yeah, I think it is.
He might. I don't know what he's got. I think he
said he was going to get one. Last I heard. Yeah.
He had what was it called? SG4 or something like that. It was his original kind of lighter mount. I can't remember the name of it. SG4 G4. Can't remember. But it's extremely. I think the Mach 2 replaced that because it had a little bit more payload. It was more forward leaning, and I didn't know about the encoders. I guess it includes encoders.
One would think at that price with that payload, it would.
So when they have this chart down here, it says overall length of instrument at focus with all gear attached. What are they talking about? They're measuring. I mean, the telescope sits real close to the mount with the rings, right?
But the length of the scope itself is another moment arm.
Yeah.
So how far away from the center, the length of the scope, huh?
Yeah, C14 is probably not too bad, but an 8-inch refractor would be bad.
Yeah, be huge.
Very good. So Mike, what's going on?
I have a friend, Mark, that's kicking me in the butt to tell me to go and get my observatory working because I've got the fiberglassing, but I was away with family and I will be away this next week. But I started in on Tom's 10.5-inch, 10-inch I believe now it's really 3.3 telescope. And I think I'm going to have to make a new pitch lap because pressing it for several hours is just not deforming the pitch. I think the pitch is a little bit too old. So I might have to re-pour a lap and do it. It's undercorrected. That's the main thing. And so I'm using a lap that's almost full size, and I'll be doing some parabolizing strokes once I get things going. I'll probably tomorrow I'll put the tool in the freezer and then chip away at the old
pitch.
What?
About the old pitch.
Get rid of the old pitch. It's kind of like that light color stuff. I'm used to the caramel looking stuff, and
isn't that William Bell's medium?
No, he means the amber colored stuff rather than the black.
No, well, the William Bell is sort of like is like caramel colored. This is like very light, almost transparent.
Oh, okay. Yeah,
Whoa.
I think that's that artificial pitch.
Okay. And so what I'm
I
going
have
to
some of that, but I've never used it.
okay. In that case, the tools glass. So I'll put it in the freezer, and I'll try not to whack it too hard with the hammer.
Yeah, Joe
when I
did that
take it
one.
out. But,
It's stuck together?
No, well, no. You put it in the freezer, and then you whack it with a hammer, and it kind of comes off.
Oh,
I
okay.
just get an old dull chisel and run it along the surface of the lap, and the pitch just chips right off.
Yeah, but did you put it in the freezer first?
Yes, yes.
Yeah, that's what I'll do. Yeah, it looks like Royce there.
What are you talking about this?
No, down. Somebody that was polishing looked like Royce from Royce Optics, right there. No, that's not him. Okay, it's somebody. It's another old guy, as we all are.
You know, this guy's only 27 years old. He's just aging quickly.
Mirror making will do that to you.
Did I tell you that people were trying to do a meniscus mirror that's like 60 inches?
50,
3/8, 60.
60 inches.
Yeah.
What the heck is this?
What?
Strange. Probably a light fixture, I bet.
Don't know. But anyways,
What are you thinking? What did you say was a light fixture?
This picture up here, that very curved.
Oh, that thing? No, that's a lathe turned
Oh.
tool for making a convex lens.
A lens, huh? Wow.
Yeah.
Wow.
And that's what they use in production. So, there'll be rows and rows of these things all grinding away at the same time.
Wow.
Jerry, have you made any refractors?
Have I made any refractors? I made one once.
Well, Jerry, didn't you do a lens for one of your new scopes, the 10, 14, or 18 of it?
The 14-inch requires two Plano lenses, and those things I haven't got to the stage of making those yet. But the idea is that you don't make them, you buy them from Edmund, because they're very simple lenses and the design is so loose. They have no optical power. So the lenses are commonly available unless you make some really weird design.
They're pretty small diameter too, right, Jerry?
They're about the size of the diameter of the hole in your main mirror.
Yeah.
So what's
Look at that
BB
star lap.
BB Astro Designs? Who is that again?
Bill Bartels.
Bell Bartels. So some kind of special pitch design, huh?
For parabolizing like f2.5 and 2.0 mirrors. That's what he does. He makes oversized laps.
Yeah. It avoids turn down edges.
That's kind of strange. You wouldn't think it'd be that, but I guess it works.
Uh-huh.
He's now working on his meniscus 40-inch, I believe.
Here's the way to go.
Mirror
Just
ball
make-
technology.
Okay.
What do you think? Is this just he's imitating a bigger mirror by using small pieces? And
It looks like that. Yeah. He's making a solar furnace, or else it's a disco ball.
Yeah.
I think it's a solar furnace, and that thing down at the bottom is probably a thing to keep this centered with the sun.
oh yeah,
With for photodiodes, so that
A soul
they all
switch.
yeah.
evenly illuminated. cancel each
point.
other out.
Very good, Mike. Interesting.
Yeah, so I've got a couple of tubs of pitch that I'm going to go and use and just do it to it. Now, is it better to pre-shape your tool for the pitch so that it conforms to the curve more? In other words,
Yes. I think yes.
What was the question?
Preform the tool that you put the pitch on so it conforms to the mirror.
Yes, you want to do that because that has that gives you a uniform thickness to the pitch, and thick pitch acts different than thin pitch. Thick pitch acts more like soft pitch. You want the pitch to be one thing.
This 8-inch that I've been working on, Mike, that's one of the things I've been suspicious of because the tool that I used to put the pitch on was not the tool that did the mirror. They're different curvatures, and so that the thickness is not uniform of the pitch. It bothers me because I think when you use one of the things that work great is when you're grinding with your original tool, and then you're going ahead and you get done and you're ready for the pitch. You just put it right over the tool. Now you have a really, really good thickness, over the entire diameter.
Well,
I don't know how that would work with the sub-diameter lap because, you're not grinding.
Work different. That's why.
Yeah. So,
all recommendations that you read in books you get on the internet and from other people that have made mirrors are all discussing the results, how to do a stroke and the results you should get from that stroke under certain conditions. And one of them is that the pitch is uniform. And when the pitch is not uniform, then you don't get the results from the stroke that you're expecting. You get something else. And you have to learn how to do that.
You have to actually modify a stroke. You really do.
You do. Or modify the pitch lap, cut a star pattern or cut out the center or do something like, what's his name? BB Optics did.
Mel Bartel,
MB Optics, yeah.
Tom Whittemore used to take a paper ring and and that changes if you have an overcorrected mirror. Let's see if it's overcorrected in the center. He would put I think he put the paper ring on the inner side and he press it with the paper ring in. So when you take the paper out, now the outer portion you're going to get all the action on the outer portions of the tool.
Right, and it'll catch up.
It'll catch up, and you have to do little things like that. And the opposite, if you have a kind of a flatter edge, then I think you have to reverse it.
Where'd Bruce go?
I think he's having a communication problem.
Okay.
Dick, how's the back?
Oh, it's doing pretty good. Yeah, we had a little thing on that already, but yeah, I'm actually doing really well. The only reason why I'm laying down is there is still some swelling in the incision area, and it's getting a lot better. I'm doing really pretty good. I'm better than pre-op right now, so much better.
Yeah, so there's Mel with his, I think that's a 20-inch, no, a 30-inch. Made out of, he basically gets a circular glass tabletop, and then he has a friend that slumps it.
That's risky.
Yeah, he's he's part of that Oregon group that are just so super into making all sorts of mirrors and stuff. Oh gosh, there's at least a couple that are making 40 inches and other type. It's just incredible.
This astrophotography looks pretty bad though.
He does a lot of good drawing. There's a couple that are really, if you go up a little bit, there's a galaxy he's done.
Is that a
Right there.
drawing? Oh, yeah.
Yeah, that's a drawing. Oh, I thought you were just joking.
Yeah.
Hey, can I, this is highly irregular, can I revisit that 12.5 just for a second?
Sure.
Okay.
When we were talking about, Tom, when we took that apart, do you remember that we have the 3 bolts that went through the mirror box? And you remember when we put it back together, I was saying, well, which way is it going to go in there? You know what? We might be able to just rotate that, just put it in a different aspect. Maybe we put it in the wrong aspect.
Well, they should have marked it for us.
Yeah, but I mean, it's just a thought. We might solve it by just moving it to a different hole.
Well, maybe because the rubber grommets have been pre-compressed over years that
Right.
Yeah.
There might be a favored location for those.
You
Hey,
should
it's
get
just-
some short metal springs and put it in place of the grommet.
Yeah.
You know what?
Yeah.
Tom was saying that. He was saying we ought to just get some springs and put them in there. And, good thinking. I mean,
Yeah.
Well, if they're not that big, tall, you might get away with like some Belleville washers. You know what I'm talking about?
Belleville washers.
Yeah, they're cupped. You know,
Yeah.
they're domed.
Oh,
I don't think these are like these rubber grommets are like 3/4 of an inch or high or
Oh,
Yeah.
okay. Okay,
Yeah,
then
like
maybe you
against-
can get away with springs. You know,
where
they
would
almost
you?
look like feet from electronic cabinets.
Oh, you're
yeah,
right.
That's
Yeah.
what it is. It's like a
Ah.
feed grommet.
what are
Yeah.
Yep, that's what it looks like to me.
What?
they?
Yeah.
What are they? They're feet for
It's like a little feed-through grommet you put
Oh,
wire
yeah.
through to keep them from getting shaped on the chassis.
Yeah, that's what they look like.
Yeah, I'm sure that's
Well,
what
they're
they are.
not a grommet, but it's
Yeah,
but
or
usually
maybe
you put
like something you'd put on the bottom of a piece of furniture.
Right.
Yeah.
I'm thinking test equipment feet.
Oh
They're
yeah,
know, hard.
there you
They're
go.
about-
Yeah.
I think they're about 7/8 inch tall. That's about approximate.
Yeah. Yeah, so that's what it sounds like. But you could use a spring. I mean, if you can get something that's
You have to find the right
springy
spring.
enough. Yeah.
Well, if you measure that inside diameter of that rubber, I can find a spring at McMaster car to go in there.
We're talking about replacing the rubber grommet completely with the spring.
Oh, just knocking them out. Okay.
Yeah.
Okay. Yeah. Well, that would certainly work.
Yeah.
If you can get the right, you can't be too light and can't be too
That's the hard
massive.
part. On McMaster car, there's a gazillion springs,
Get a couple of
different lengths.
spling constants, and you should be able to do it.
Yeah, well, being a short spring, it's actually going to appear to be stronger than a long spring. It's just the way it works out.
But some of them are really stiff, and others, even though
Yeah.
they're wider, they're just like, there's no resistance at all. They have loads on them. When you look at on
Yeah.
McMaster car, they'll tell you the loads, and you really, for something like this, you really want a pretty good, probably a 60-pound load at least to push against with those with the knobs, and
Just,
go ahead.
I said, just remember, if it's too stiff, then it's going to be a real bear to turn. with
Yeah,
the screw.
True. Yeah, I've got a bunch of washers here. Got a bunch of wing nuts. Got the thing I have springs, but I don't think that they're the right springs for this.
Now, as you remember, these go to the triangular plates that hold the mirror on, correct?
No, that's what we can't figure out. There's the triangular plates. They're floating on something, and Tom and I didn't take it apart, so we don't know what's underneath those plates.
I'm
And
gonna
Jerry-
have to-
What's the mirror on?
I'm going to have to say goodnight a little early.
Okay.
My neck
See
is starting to hurt. See ya.
Okay.
All right.
Okay, right there. There's your triangular plates.
Right.
Okay, but I think what the deal is, yeah, okay, so those plates are going up and down. with the screws. So you could put a spring there.
No, the bolts in between the plate, right there. See that
Yeah,
bolt?
those are the ones you want.
Oh,
Those are the ones that adjust against the rubber grommet.
Yeah.
It's a really
Oh.
weird situation.
Oh, okay, so this whole plate moves back and forth. It gets
Yeah.
okay. Okay, it
And you're talking about a wooden box on the bottom. I'm not sure how thick the wood is.
Okay, so yeah, okay, so I see your point. You know
But
what
when I put it back,
you might be able to get away with if the spring is not stiff enough, just put another one next to it because it's pushing against that plate.
yeah.
Yeah, I think you got to end up with a height because these things stick out where the floating plates are using these bolts.
Yeah,
And
yeah,
you've
so
got
it's
maybe
gotta
up to maybe an inch maximum, 3/4 to an inch of a
Mhm.
rubber grommet. So you don't want to have more than 1/4 inch of compression before you'd start hitting these bolts.
Yeah, that's
Yeah.
true. That's true.
so yeah, yeah, you should be able to get a bunch of springs like that.
Hey Tom,
Uh,
hey Tom Totten, if you wanted to maybe go over there sometime in the middle of the week, just take a look in there and see what we can see. I don't know if I can do it all before the star party.
Take a cell phone and look sideways at the mirror underneath it.
I think so. I think so.
Hard to get that low. Well, there's a lot of room in the box, but
Yeah. How did we get that plate out? Was it a hard thing to get that out?
no, just loosen the knobs and then it pulls up. Yeah.
Okay.
It was stuck on the old rubber grommets there, but
That's what it was. Yeah. But yeah. Well, if you do, just I wouldn't mind. I wouldn't mind going over and just taking a quick look.
You know what you might be able to get away with in a pinch? An old inner tube. And just cut squares and punch a hole and just put enough to make it equal to the height of the old squishy thing. And that should be, and
I like the idea of feet on a furniture or
well, no, it has to be a flexible rubber. In other words, it has to be compressible, and a lot of those feet are hard. Yeah.
Well, anyway, regardless, that's what I think we should do is just go over. Maybe I'll shoot your ring tomorrow, Tom, and see what you're.
I've got golf tomorrow. I'll go golfing.
Oh, okay.
Noon to 5 or so at least. And
well, I think it's raining Thursday, so
yeah. So Friday maybe
Friday.
We're getting the rain tomorrow.
Up in Sacramento area, Rio Vista.
Oh yeah, we've had rain here, off and on, San Francisco is raining this morning, so
I'm glad we're getting water up there. God, man, we need it. I was telling
we are so behind on water. You have no.
It's really bad.
Oh yeah, they were showing where they were measuring the snow.
Yeah,
and there was and they have this long pole. They were standing on this patch of snow and says, "This is it."
Oh no.
Well, there was a guy in the news down here that I saw, and the guy was standing on soil. And the guy said, "Well, how far behind are we?" And he said, "Well, you see this pole right next to me here?" He said, "We should be standing on snow up there." And he pointed way up.
Yeah, it's
like about 8 feet in the air. And he said, "Right now, it's on ground." And he goes, "That's how far behind we are."
We're in extreme drought, except for just a couple small places near the coast north and San Diego, but everywhere else.
Maybe we'll get lucky and get some kind of summer storm. That would be really good. It's happened. It's happened. Well, anyway, look at those. See the ones, Tom, the ones, I have a bunch of those kind that have the little, you know, the little connectors, but the ones we want are like that you have your cursor on.
Yeah,
That's
you want
the kind of-
compression
Yeah, you want a compression ring.
as
And
opposed
you
to
want it,
the
you
other
want it,
ones are.
you want it flat at the end.
Yeah, yeah. Relatively flat. That's just how they sit. You'll see that. So that one right there looks really good, because then you can put what you do is you have to put a washer on the top that is large enough to go over that. And
Yeah, you want to
yeah.
protect the wood at the bottom.
Yeah,
Oh, yeah.
You have to have big fender washers that don't, you know, that have that are centered on your bolt.
Yeah,
And then, you know, so we'll see what we can. I think we need to go over there and take a look at it, Tom, maybe Friday.
Do some careful measurements.
Yeah, exactly. Just see what's up.
But yeah, but still to check out that floating points, how that works.
Yeah.
I'm wondering if somehow like the bolt, that flathead bolt that's coming through, it's somehow that it's rounded somehow. So that's why it can kind of tip back and forth.
That's exactly right.
You know, is the, let's see where the other side is. That these guys are somehow rounded underneath the head of this flathead is somehow,
because they're floating. That's why they can.
and or the conical shape of this flathead is longer than the piece of metal that is going through, and so it sticks through, and then it kind of, and then of course you can only tighten the bolt down so far, so so it's not rigid, so you have some movement, and that's why these have nylocks on them to keep them in a certain place.
Yeah.
Yeah, we have to study
but
that.
that's not the collimation adjustment. The collimation adjustments with those, right there.
Yeah, that's just for the flotation.
And those things are hard to visualize, Mike, because, you know, if I drew it out for myself, and I started thinking, okay, I'm tightening the knob, and it's compressing the bushing, and so it's actually pulling that side of the mirror box back. But the result is that when looking down the tube, the red dot of the laser, it's moving in the opposite direction that I'm pulling. And I'm going, what? You know, why is that happening? It should be the other way around. You should be tightening the other side, the other knobs. And so I don't know, maybe it's because the reflection is backwards. Maybe I'm not seeing that right. But I'm not visualizing it. I have to draw the whole thing out again so you can actually see what's going on. What happens looking down the tube at the red laser, that you're seeing that you're trying to adjust your secondary reflection.
Right.
Okay, that reflection is up at 2 o'clock, almost off the mirror. And when I adjust the 4 o'clock knob as tight as I can get it, that pulls that laser inwards to the left, downward to the center, and just barely collimates. And the ones that the knobs that are at 12 o'clock and 8 o'clock are loose.
And the reason is because the rubber has lost its elasticity. It's not pushing anymore.
Yeah. Okay.
Yeah, I think that's what it is, because you've only got so much movement in there. You can't get it to, you can barely get it to a culminating position.
Dick, I'll buy that. I'll take that. The thing is, I'll go on a McMaster car, see if I can't find something that's got. Yeah. I think those bolts are about a 1/4 inch diameter. So
and get a couple, if you can, just get a couple sets, one with a heavier spring constant than another. So you can kind of like try it out and see what works.
Yeah. I'll try it out. I'll see what I can do. That sounds good. Well, as far as I'm concerned, I'm through.
Okay, guys.
Oh, you guys see this, Tim?
Okay.
I found the spring here.
Okay.
You know what? That might be
Well, the one up there. Yeah, look at that. Look at that.
Oh my gosh.
Isn't that it?
You have to find the right height and diameter.
right.
Yeah.
That's what he used. I mean, it probably works for a while, a long while.
I think a spring would be better if you could get it going,
Yeah.
because at least it would last longer.
Yeah.
What site is this?
This is just a search engine, DuckDuckGo images. So.
Okay.
Rubber feet, right?
Rubber feet. Yeah, McMaster Carr, it's tough to navigate. It's such a large site. It's huge.
But they
And
got
it takes-
everything.
They've got everything. You really have to say the exact thing that you want. And even then,
Yeah.
like there was,
And-
you know, on the aluminum poles that we use for, for the Dobbs, there's these little umbrella-like screw inserts that you have to press inside the tubes.
One way,
they-
yeah.
And if you were to just put thread inserts, you'd never come up with it. So there's a special word. So I have a pack. I still have a pack here somewhere. And every time I have to reorder them, I have to go look at that pack to get the proper wording, because I got lost one day. I spent an hour and a half trying to find them, never found them. It's some kind of like screw insert, but it's a captured screw insert. Even then, that wouldn't do it.
Oh, well.
Yeah, I think I'm going to look at a couple of I might take a look on if I do this star test with this scope, the 8-inch, when I take the mirror out again, I'll take a good look at that. What is that? Something? It's not college optics, university optics mirror cell, because they have some pretty good spring mechanisms in there, and we could copy that design. That's a pretty good design.
I think the springs are a little bit longer than 3/8 of an inch, but you could find something.
Yeah.
So,
Okay,
Mike,
gentlemen.
your next Windy City program, you say the first Monday of the month. Is that what you're doing?
Hold a second here. Or is it second Monday? Yeah.
Second Monday?
Yeah, I think so. God, yeah.
You'll let us know.
Yeah, I'll let you know. Yeah, I haven't got around to asking McPartland and on anything, but I got quite a bit of material, and so I got
occultations.
I got to go work on it some more.
It's not work; it's play.
Oh boy, yeah, but every month, man, it's like, it's like putting out a magazine in a way.
I'm getting excited because the last Monday that they did on YouTube, on YouTube, Jerry was talking about doing the history of the telescope and using an entire program on the history of the telescope, and I love that. I love that topic. So I have a partial slideshow on that. I
keep finding out things about different scientists that you kind of, there's sort of like a mention in a footnote somewhere, and all the things that they've done, and you try and figure out, I still have to go through that timeline figure that I made, and start updating it, where these guys and where they, what they invented and all that, like Steiner and all the other people I talked about the last time. There's really a progression that these guys work with each other, and
pretty amazing. They didn't have very good communication back then, but somehow they
had some form. No, actually, they wrote letters. Letters got to each other, and some of them actually did travel, even during wartime. And it's just like, and also,
I'll be right back.
Traveled, they had to worry about bandits and pirates and stuff like that. Being waylaid, through a country, because where there's war, there's the highwaymen and all that, and it's truly amazing that they did all that. I mean, who was it? Leibniz wanted to go visit Newton. I think they actually met.
That's my latest.
Oh, wow.
I just got done with the back. Got it all planed down and smoothed out, and then I've been inlaid the rosette. And
What kind of wood is that, Tim?
it's Engelmann spruce. And then on the back, I have a plastic gizmo that goes on the back of this, and it tells you where all the different fan struts go. I built that and then etched into it where all the fan struts go. So all I do is put the plexiglass, what do I call it, jig over the top of this, and it has little holes. So all I do is just circle the holes and then connect the holes with lines, pencil lines, and that's where all the little fan struts go.
So is this going much faster than the first one?
Yeah, and basically because I had to build so many tools. I built spool clamps. I built these cam clamps. I built this thing called I can't remember what it's called. It's a table that has a bottom plate and a top plate that rides on poles, and you buy fiberglass rods. So when you're clamping something, when you're clamping these fan braces, how do you glue them? You don't have these long clamps, right? So you put it down on a gizmo. You put it down on a Solera that has a curve in it, wow. And then you put the glue down, and I used hide glue at this point, and then you bend the little the rods in, and they sit on top of the struts. And if you have it right, if you have adjusted right, you just bend all these rods in, and they push down, and it glues them. And the animal glues are much better because as they dry, they pull things together. Really nice. Hmm. So anyway, that's where I'm at. I thought I'd share it with you guys.
Beauty.
Looks like a 0 to 24 hour dial on that thing, that RA dial that you're using there.
Yeah.
Right ascension.
That would be an interesting one. Use that for your car hole.
There was a guy that made Dobbs. And you remember that, Mike? When we were looking at the workshop one time, and some guy made Dobbs where the bearings he made were wood carvings of the moon and stuff. Oh, that guy was an artist.
Wow.
Yeah. Hardwood,
Yeah. And they were fascinating scopes because they were all like, the guy was an artist. I mean, he just like did all these, half moon with all the faces on them and stuff. They were a trip, not me. And I got an old inner tube.
Okay, I think we've reached the end of our guitar lesson today. So
yep.
Okay.
That's it, man.
Okay.
We're done.
All right.
All right. So we'll tune in next Tuesday, hopefully.
Dick,
Okay.
Tom,
See you
Okay,
soon.
guys.
Tim.
Bye-bye.
Bye.
Ending.